All righty here. Okay, so let me back up here. All right, are you seeing the slide that has the verification on it for MELD, C, and D? Can anybody hear me? Okay, I saw a chat message that said that you can hear me, so I'll keep going. All right, so on the left, you will see the ceiling verification for ceiling height less than 1,000 feet. The MELD product is in the green curve there, and the takeaway here is that the MELD is showing quite a significant improvement over the base lamp, and which is the blue curve, and also it's better than the wrap, which is the yellow. So on the left, you have ceiling height less than 1,000 feet, and on the right, you have visibility less than 3 miles. So pretty much the same picture there. So the green curve, which is the MELD, is an improvement over the base lamp. Just wanted to show a couple of our prototype forecasts here. So this should be looping for you. The one on the left is for ceiling height, and the one on the right is for visibility. So we're currently evaluating these products. This was being looked at as part of a demonstration with the aviation weather test bed. So we're going to be tweaking this going forward. It's not perfect, but we're currently looking at this right now and to evaluate it. All right, so I'm moving on to the Alaska gridded lamp convection and lightning product. So this is also a JTTI funded project. So basically for this, we are extending the CONUS convection and lightning framework to the Alaska domain. So convection is defined as one or more cloud-to-ground lightning strikes or composite reflectivity greater than or equal to 35 dBz. Base lamp is a combination of NAM-MOS and observations. The MELD is a combination of our base lamp and the wrap MOS. So we are leveraging, convection and lightning is leveraging the wrap in Alaska. And so we produce 1 hour convection and lightning probabilities and potentials. Just a quick slide here to show we regionalize the development. So for lightning, we have a land region and water. And for convection, we have 3 regions, land, water, and an MRMS region where we have sufficient radar coverage. Here's a verification slide for our 1 hour lightning product for the June-July 2017 period. The black curve is the final MELD. What you see in gray there is the base lamp, and the other curves are the MOS components. What's most striking here is you have much higher skill in the first couple hours, which is due to the significant influence of the OBS. But the OBS skill, which you see in red, drops off pretty rapidly, and then the MELD and base lamp trend toward the MOS in the later projections. Next here, we're showing some convection verification. The plot on the left is for our MRMS region, and the plot on the right is our land region. So there, you can see, a much higher skill in the earlier projections. Again, that's due to the influence of the observations. And then the takeaway here is that the MELD, which is in the black curve, shows components for both regions. Here's an example here of our product. So for lightning, the top plot is for a 1 hour projection example, and then the bottom is for a 24-hour. To the right, you see the verifying lightning OBS. So you can see you have fairly sharp probabilities here, which tend to match up pretty well with the observed lightning. Here again is that potential category product that I described before. You can see there, again, it matches up fairly well with the observed verifying lightning OBS. Here's an example convection probability product. Again, the top is for 1 hour and 24 hours at the bottom. Observed convection OBS on the right. So this product is currently undergoing, we're finally getting this up and running on the supercomputer, and we're making some images to look at on a website. Here are the convection potential and the verifying OBS. All right, moving on to the gridded lamp meld sky cover. So this particular project is funded by the FAA, Federal Aviation Administration. So for this, we are expanding the gridded lamp sky cover guidance to cover the full NBM CONUS domain, and also extending this to 38 hours. So here we have a base lamp that is just a combination of GFS MOS, which is newly developed MOS, plus observations. In the meld, we're combining the base lamp with the HER. For the development, we do cumulative probabilities of sky cover less than these few scattered, broken, and overcast. This is developed regionally out to 38 hours, and we also make thresholds for making discrete categories, so clear, few, scattered, broken, and overcast. The verification I'm going to show is Heidke skill score, and we compute that for the meld, the base lamp, the MOS, and persistence. And our cool season period was February through March 2017 and October through December. And we have a warm season period, April through September 2017. So here is the verification for gridded lamp sky cover. Warm season on the left, cool season on the right. This is 12Z cycle. What you're seeing are Heidke skill scores. The meld is the green curve. The base lamp is the blue. So the meld is generally an improvement over the base lamp, and also an improvement over the MOS, which is the black curve there. Here is an example product of our gridded sky cover amount for the CONUS that covers the full NBM domain. In addition to this, we also make probabilities, gridded probabilities of the cumulative probabilities, as well as discrete for each of the 5 sky cover categories. All right, moving on to the gridded lamp probability of precipitation. So this product was mostly meant to support the National Blend of Models. So for this, we use MRMS gauge-corrected 1-hour QPEs to define the occurrence of measurable precipitation. Here again is very similar approach to the other products. We make a base lamp, which is a combination of NAM MOS and observations. The meld, we combine base lamp with the HER. And we're making 1, 6, 12-hour probabilities, as well as a 1-hour categorical yes/no. Just a quick verification slide here. This is for cool season. And again, the meld here in this case is in the orange curve. Base lamp is in the green curve. And there's pretty good improvement here of the meld over the base lamp and over the MOS components. Here's an example of our 1-hour probability of precipitation product. So we were pretty happy with this, and the probabilities are pretty sharp and generally reliable from the statistics that we looked at. So, all right, in summary, we have those items that I went through, the Alaska ceiling and visibility out to 38 hours. We have the Alaska convection and lightning out to 38. The meld sky cover for CONUS to 38 hours, and the 1-hour probability of precipitation to 38 hours. The code handoff to NCEP is planned for September 2020, and the implementation on the supercomputer is planned for December 2020. Just a slide here that I'm going to show for our future work. Our plans for the rest of this year and next year are to try to refresh our temperature, dew point, and wind guidance at stations. So this is something that's been on our plans for a while. So we hope to be able to get that done for our next implementation after this upcoming one. We're also going to try to refresh our precipitation type guidance out to 38 hours. A couple projects that are funded by the FAA. We're going to create deterministic and probabilistic gridded lamp for the highest impact weather ceiling and visibility, and flight category conditions over 15-minute periods. And finally, we're going to investigate using some new satellite data sources to try to improve gridded lamp between stations for ceiling height over the CONUS. So that's kind of what we have planned for the future. And just another slide here showing our website and where you can go to find our experimental stuff, and as well as my contact information, and Judy Gardelling, who is the LAMP task lead. So thank you very much for your time. Apologies for the difficulties, and I'd be happy to answer any questions.
Thank you so much, Dr. Shafer. Yes, sorry about all of the technical difficulties. It just happens when we have this many people on, and we're passing around the role as much as we are. We do have one question in chat right now. What's the process for adding LAMP stations? Spaceport America KSHA in New Mexico is not a station with the buffer model sounding lists.
Okay. Well, in general, we try to get stations added to the LAMP system once we've been able to develop MOS model output statistics for it, and once we've been able to collect a long enough sample of observations to develop off of. So we maintain a spreadsheet that actually has all of these different station requests in it that we never seem to have enough time to do. But we keep track of those requests, and as we move forward to different upgrades, we try to get those added to our bulletins and the buffer message. So I'm not sure if that answers the question or not. But.
Well, if any more clarification is needed, it looked like it was viewer 154. Please feel free to add to the chat. And it looks like we have one more question here. When will we see absolute forecasts for ceiling and visibility rather than categorical?
Okay. I believe we do make grids of the actual ceiling height and visibility categories. Those are also the probabilities, I believe, are input to the blend. But maybe check with Adam Schnapp on that for sure, but I believe we do produce those.
All right, perfect. I'm not seeing any other questions right now, so I'm going to go ahead and stop the recording. Again, thank you so much for presenting, and thanks for the audience patience.